Now that we've finished going through the muscle physiology of contraction, quick summary. Remember, it's the starting with neuromuscular junction. We then go into the action, potential, conduction, or propagation. Then you head down the T-tubule, looking at the finishing portions of the excitation-contraction coupling, which finishes then with the actual cycling through of the cross-bridge cycling. That's great because we went through how to contract, but how do you relax your muscle? How do you undo all that? Well, the short answer is do it all in reverse. But there's a few key things to keep in mind. First off, nerve impulse ends. When you stop from your brain or spinal cord, either one, sending a nervous impulse to a muscle, that means there's no more action potential reaching that muscle, which means nothing's going across synaptic cleft. There's no signal going across synaptic cleft. We have to stop the muscle contraction. So you're not having anything go down the muscle fiber. Nothing's traveling along the sarcolemma because there's no initial depolarization of the synaptic cleft there at the end. So therefore, it has to have nothing else continuing on. So with nothing continuing on, that means the T-tubule doesn't release calcium anymore. If the T-tubule is not releasing calcium, that means you're not going to keep increasing the calcium levels inside the muscle. All that calcium that was there is being actively transported back into the terminal cisternae, the sarcoplasmic reticulum. So all that calcium that was there is being pulled back in by using ATP, active transport. That means you're now lowering the calcium levels inside the muscle. By lowering the calcium levels, less calcium is bound to troponin. Troponin goes back to its original shape. When troponin goes back to its original shape, that means tropomyosin also gets pulled back to its original point. By pulling tropomyosin back to its original point, you're breaking the cross bridges. Myosin can no longer be bound to actin. If myosin and actin are no longer bound, that means myosin is not holding on. Actin slides back to its original point. Remember, muscles are elastic. They want to have recoil to them. So if you're not actively holding that troponin to the myosin, and that actin and that tropomyosin, that whole thin filament is not being held there, then it's going to slide back as you release. So we're releasing back to the resting state. Now, with that being said, though, side note here, you're not releasing every myosin head. Every muscle in your body has a resting muscle tone. So while yes, we broke cross bridges, yes, we've reduced calcium levels, that allows the muscle to relax back to its resting state. There's still overlap of thick and thin filaments. There still will be some myosin heads bound. This is just undoing the increased amount that caused the contraction. So let's go through a little more detail and run through one contraction to relaxation here. So if we throw this up to a bigger view again, see what's going on. Starting with the neuromuscular junction. Here the signal comes down, then we're going to cause the voltage regulated calcium channels to open. Calcium pours in, causing these synaptic vesicles to fuse and allow exocytosis. The blue dots are acetylcholine. The acetylcholine binds to the chemically gated channels. That's allowing the flow of sodium and potassium through. They're going in and out. That's creating the graded potential. If you can add those up enough or summate them, add them together, summation, you might reach the threshold. Threshold, negative 55 millivolts in the skeletal muscle. That then can create an action potential, which will travel down the muscle membrane. Remember that action potential conduction is based on the sodium ions having a high concentration inside the muscle cell. And I wanted to go from that high concentration inside, so a whole lot of them right here. They want to flow down to a point of lower concentration. As they flow down to a lower concentration, they're also going from the positive environment to where the future environment is negative on the inside. So you want to go from positive to negative. That's the electrochemical gradient. So you're allowing all of the sodium ions to move down. A wave of depolarization. As that occurs, it's then going to go down into the T-tubule. We still are having those sodium ions moving. That's what's moving, sodium ions. They're going to trigger the opening of the voltage-regulated calcium channels. So this is calcium down here. It's releasing out into the muscle. As that voltage-regulated calcium channel is open, the calcium is flooding the muscle. It's heading down to bind with troponin. That's that little yellow piece there. Once it binds troponin, it's going to go through a conformational change, moving tropomyosin out of the way, allowing the myosin head to bind. Once the myosin head binds, we now go in the cross-bridge cycling. The myosin head will go through the power stroke, moving the thin filament. And it keeps happening over and over. You move the thin filament, then you have to detach, which is when the ATP binds, go through hydrolysis, releasing energy from the ATP, then it allows the resetting or recocking of the myosin head to go again. But now, let's go through relaxation. All those initial signals are gone. Calcium is now being transported back up into the terminal cisternae. As that calcium is transported back up, it allows the tropomyosin and troponin to go back to the regular shape. So we're basically resetting the muscle, breaking the cross bridges, allowing the thin and thick filaments to slide back past each other. You've got everything reset. You have your space here again. You're not having everything bound. Troponin, tropomyosin are back in their regular places. You're blocking the binding site on actin. The muscles have reset back to their resting state. You're resetting back to homeostasis. That's muscle physiology in a nutshell. So we're looking at how all this electrical signals came through, all this movement of ions, into the movement of the muscle, then how you relax and go back the opposite direction. Get rid of the calcium. You're breaking the cross bridges. You're letting the fibers slide back to their resting states.